Hello YouTube, we have a fun video for you today. In front of me here, I have the Raspberry Pi 5 single board computer. And for those of you who don't really know what that means, it just means that the RAM and the CPU and all the components required to get the computer working are just soldered to this little credit card size computer. This one specifically is the Raspberry Pi 5 4GB variant. There's an 8GB variant that exists, as well as a 2GB variant that is on the horizon. So what are we going to use this little single board computer for? Today, I thought it would be fun to actually take the production version of Bitcraft. So that would be like the actual version of SpacetimeDB and the production Bitcraft module, and actually host it on this Raspberry Pi 5. So essentially, we're going to take the Bitcraft server and put it on this Pi, connect a bunch of bots, and see how many bots we can support before we start noticing some lag. For those of you who don't know, Bitcraft is our community sandbox game, which is currently in closed alpha. The current closed alpha is a little different than alphas we've done in the past, because during the current closed alpha, content creators are actually allowed to make content using Bitcraft. Due to this change, we're also able to show off the real game on our Twitch stream and here on YouTube. If you haven't already, definitely consider checking us out at twitch.tv/SpacetimeDB. So yeah, let's jump into it. Okay, awesome. So here we are in Windows. The objective for today is to prepare the Raspberry Pi for the stream later this week, where we're going to be running Bitcraft on the Raspberry Pi during a stream. It means how we're going to run around and throw some bots in and see how many players we can support on the Raspberry Pi 5. The first step in this is going to be preparing the Raspberry Pi. So we've got to install Raspberry Pi OS. We have to install SpacetimeDB and do everything we need to do to get that ready. So the first step that I've done here is I've just gone to raspberrypi.com/software and I've downloaded the Raspberry Pi imager. So now we have the imager up. The first step here is to choose a device. Today we'll be running on the Raspberry Pi 5, so we're going to go ahead and select that. Operating system choice here. So typically I'd recommend going with Raspberry Pi OS itself, 64-bit. But today I'd actually like to do Ubuntu instead. So we're going to do Ubuntu Server 2404 LTS. Then we're going to go ahead and select our storage. So this is a 256 gigabyte SD card that I literally just opened out of the package. So it should be brand new. So I'm going to go ahead and hit next here. Would you like to apply some OS customization settings? I'm going to hit edit settings because I want to set the host name and username and password. So I'm going to quickly enter a password. It does show in this window, which I don't know why it is like that, but there we go. Cool. So now I've got my password in here, username. I'm going to go ahead and hit save. The host name we're going to use is Raspberry Pi 5. Okay, would you like to apply the OS customization settings? I'm just going to hit yes here. All data is going to be deleted. Like I said, this is a brand new SD card. We'll go ahead and hit yes. And now we'll just wait for the image to write. Okay, cool. The image is finished writing. Now it's verifying, which I'd probably recommend doing this step, even though it takes quite a while. Okay, excellent. So it is finished verifying the contents of the SD card, the writing the OS and all that stuff finished. So we're going to go ahead and continue. So now I think I can just go down here and eject, or maybe it already ejected. Okay, cool. I'm just going to unplug this. Okay, awesome. So I actually have the Raspberry Pi right here in front of me. I'm just going to plug in the SD card. I'm also going to be plugging this into the official Raspberry Pi power supply, which I've already hooked up here. So I'm going to go ahead and plug this in to both Ethernet and power. And I will bring the Raspberry Pi up for people to see. Okay, cool. So that's the Raspberry Pi. We've just plugged in the SD card that we wrote using the Raspberry Pi imager. You can go ahead and open up the terminal to log into it. Okay, awesome. I made a small mistake in that I didn't actually plug the power supply in. So the Pi is powering up now. I'm going to go ahead and try to find it on my network. Okay, awesome. I have found the Raspberry Pi on my network, so I should be able to do SSH Boppy at 192.168.2.100. and we should be able to log in here quickly. Okay, awesome. So the first thing I'm actually going to do is I'm just going to update it. So sudo apt update and sudo apt dis-upgrade-y. So I'm going to go ahead and just run through the update procedure. Okay, awesome. So we've finished updating here using apt, and now we will just quickly reboot. And then after we are done rebooting, we will install SpacetimeDB. Okay, awesome. So the Pi has rebooted, it's been updated. We've gone ahead and we've logged back into it. What I'm going to do now is just go to SpacetimeDB.com because we need to install SpacetimeDB. So I'm just going to quickly go to the install tab here at the top. You can also just go to SpacetimeDB.com/install. I'm going to go ahead and just dump in the instructions for Linux. So that's this. Okay, go ahead and just drop it in. Okay, we're going to hit enter to install the CLI binary. The default here is good. Okay. All right, so there's one thing we want to change here, which I think this won't pick it up right away. Oh, no, it does. Okay, excellent. So one thing we want to change here is I'm going to go spacetime upgrade to 0.10.1. There's a reason for this, and that's that the current version of SpacetimeDB that's released isn't supported with Bitcraft at the current moment. Obviously, in the future it will be, but Bitcraft just isn't ready for the current version of SpacetimeDB, so we actually have to downgrade. So we're going to go ahead and do this. Okay, excellent. So we've downgraded to 0.10.1, which is what we need to be on. So the next step here will be to actually get Bitcraft up and running. So let me do that. Okay, awesome. So we have the correct version of SpacetimeDB installed on here on the Raspberry Pi, which is version 10.1. So we're going to go ahead and just do spacetime start, listen, adder 0.0.0.0:3000, which this is going to start SpacetimeDB on the public interface so that we can connect to the Raspberry Pi remotely from my Windows PC here. So I'm going to go ahead and just change over tabs here. We're going to go ahead and add the server. So we're going to do spacetime server add HTTP 192.168.2.100:3000. And then we're going to call the server Pi, sure. Okay, so this has actually added the Raspberry Pi to our Spacetime CLI toolchain so that we can publish to it. And actually, if we do Spacetime server list, we'll see we have testnet, a local server, and then the Raspberry Pi here for us to publish to. So now I can do Spacetime publish -s Pi, module name Bitcraft, and we'll go ahead and skip Clippy. So this will go ahead and actually publish the actual Bitcraft module to the Raspberry Pi. So once that finishes here, we'll take a look at it. Okay, cool. So that didn't take very long at all. Cool. So now we have the Bitcraft module published to the Raspberry Pi. The next step will be actually to deploy the world. Once we've done that, then we'll be actually ready for the stream. So then we'll take a look at this on stream and be able to see, I guess, how many players we can handle on the Raspberry Pi. Awesome. So here we are on Twitch. And if you haven't already, definitely come check out our Twitch page at twitch.tv/SpacetimeDB. We stream every Wednesday and Friday. Today we have a very special stream. We will be running Bitcraft on SpacetimeDB on a Raspberry Pi 5. So we are going to give this a shot. Yes, the YouTube video has now started. So if people want to get their nice comments in, go for it. But yeah, so today, very special stream. We'll be taking literally what is running today in the production environment for Bitcraft, and we'll be running that on the Raspberry Pi. And I haven't done anything special here. This is literally just the default Ubuntu 24.04 default image, and I've installed SpacetimeDB, and that's what I've done. So we'll go ahead and plug it in.
To be clear, this is the server of the Bitcraft game, so not merely the client, but the actual server where we run the whole MMO.
Okay, cool. So we've gone ahead, we've got it plugged in. So essentially what we should be able to do now is, let me log into there. I don't have like any automations or anything set up like that. I'm literally just going to log in, just start a screen. And I'm just going to call start SpacetimeDB. Okay, we've got SpacetimeDB started. I've just got a little script here to actually load the module. And we'll bring up htop here, which is going to be a little interesting. So let me just do... So we'll take a look here and we'll see that maybe not enough RAM, but it's okay. It's okay. Which model Raspberry Pi 5 is this? That's a great question. That is a great question. This is the 4 GB model. So this is essentially they come in 3 configurations: 2 GB, 4 GB, 8 GB. There's been rumors that 16 GB is possible, but Raspberry Pi themselves have not shipped a 16 GB variant. This is the 4 GB variant. So essentially, Bitcraft just barely fits in memory here. So there's that. But it is legitimately running now. Which Spacetime server are you running it on? Let's take a look. Spacetime version. Just whatever's on the page for SpacetimeDB.com. So this is 0.10.1 is what we're running. Great question, Denny. Okay, cool. So we've actually got the Bitcraft database loaded in memory now on the Raspberry Pi. Let's go ahead and get connected. Let's give it a try. Okay, cool. So I think we're pretty much ready to generate a load. Tyler, how many bots would you like to start off with?
I don't know. What do you think? 32?
32? Okay, I'm happy with this.
Powers of 2.
Okay, so this is the current htop for the Raspberry Pi. We can see here that we're like essentially not doing much, not doing a whole lot. Cores are pretty low here. And I'll keep in mind that this is like on its own, just having me and Tyler in here, like playing on a Raspberry Pi is actually incredibly cool.
Where are you? I wanna
Oh yeah, we should like prove that we're playing together. I'm at 538, 1693.
Okay, I gotta go very far east, I think, because I'm at 536, 1242.
1242.
So I'm gonna run over to you.
Oh, I see you. Okay. Woo. All right, we've made it. We made it. Okay.
Here he is.
Okay. All right. So this is Tyler. I promise you that we're running on this Raspberry Pi right now. Even though it doesn't look like the Raspberry Pi isn't doing anything, it looks like it's doing essentially nothing right now. We are playing on this Raspberry Pi. I guess what we could do next is just spin up some bots. Shall we do that?
That sounds great.
Okay, excellent. Let's go ahead and we'll start with... You want to start with 32?
Sure, let's do that.
Okay, cool. So essentially what this is going to do is it's requesting from a very large machine in AWS. It's saying, give me 32 Docker containers, which are going to run this fake player thing. So it's going to go ahead and connect some bots to our Raspberry Pi here, and actually have a script that we can run, which is count connections. So we are currently at 35. And this is actually going to be one more. Technically, this should be 34 because it's 32 bots plus me and Tyler. So essentially, that is how many people are connected. We'll see that the htop has gone up just slightly. So the htop now is showing that there's a little bit more activity. And actually, I think... Is this Wisp? Oh, no, this is Wisp. I was like, oh, I can see a bot, but no. I can see Wisp here. It seems like I can't really see any bots yet. I think we probably should have stayed near a spawn point. Otherwise...
This is a spawn point, I think.
Is there a spawn point over
be.
here?
I think
there's a bot. Oh, there's bots. Yes, there are bots. Okay, cool. Let's go.
This a bot? Player 103618663.
Yeah. The bots do not know how to choose a username, so the bots just they get whatever username. I think maybe Bitcraft assigns that. I'm not quite sure. But this is legitimately a bot here. Like this is not a real player. This is a bot, and this is Tyler.
Yes.
Tyler is doing the tutorial. So there's one here, and I think there's actually one over there as well. Okay, so this is 32. This is good. Very much obviously playable. We'll go ahead and go. I guess I should go collect something. Like maybe we should get some food. Go ahead and help gather some flint here. Not enough stamina. Okay, I should probably rest. And we'll see that like all these interactions, like resting and all of this, really no lag at all. Awesome. So it seems like we're at 32 bots right now. I guess I should like have this on the screen, like the amount of bots that we have in. Let's go ahead and check the HTOP again. So we've got like actually a little bit of load here. We're sitting in between 10 and 20% on pretty much all the cores. Sometimes hitting in the very low 20s. So I would say, should we go ahead and add a couple more bots here, Tyler? What do you think?
Let's do it.
How many more do you want to add? We're at 64 right now. How many would you like to add?
Double it. Let's go to 128.
Double it. Okay. So I actually have two servers requisitioned for this. We'll go ahead and spin up 64 on the second one here. Let's see what we've got here. So we have essentially 130 connections. One of these connections is actually the server's port itself. So we've got 128 bots connected right now, plus me and Tyler. So 130 clients connected. Okay, we're sitting now in the 30s. Okay, we've got, this one's low 20s. Okay, this one hit 40. So like mid 30s, maybe low 40s percentage. So this is 128 bots. 128.
How many cores are on the Raspberry Pi?
It's only got 4 cores. We're going blazing fast here on 4 cores.
Well, I think so 128, right? So we can probably put about 500 people, or maybe like, I think it's like 700 is where we sort of top out on the current thing. Something to bear in mind is the number of people you can fit into a server. There's like an n squared value in there. So basically, if everybody's moving once per second, or however often they are moving, then everybody else needs to hear about everything they're doing every second. So it could be 500 times 500. And so as you get to bigger and bigger numbers, you need more and more resources. But I would say that SpacetimeDB is much more constrained by single-threaded performance than it needs to be. Once we stabilize 1.0, we're going to really unlock some of that multi-threaded performance, which is going to mean that our servers are going to do way, 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 way more people than you would have on a Raspberry Pi.
And just imagine this as well. How much does a computer cost? I think it's like, I don't know. I think it's like $60 or something like that. Imagine it's like if you were able to scale this horizontally with just buying like a ton of Raspberry Pis. And this would not be the most efficient way to do it, but let's just say that you wanted to do it this way for some reason.
Yeah.
Think of how easy it is to just be like, okay, add, X amount of players by just putting in one more. You know what I mean? Especially with like how cheap a Raspberry Pi is. I know it doesn't scale horizontally perfectly like that, unless you like spatially partitioned. Let's say that you had a game where like the world was very like laid out and you needed to just keep expanding it over time. In that sort of situation, this might work.
Well, let's say that, actually, it's like not even the worst idea. Let's say, for example, there's some problems with it, but let's say this. We were able to get 2,000 people or so on a single Raspberry Pi. We were able to optimize things and get it to be that scale. You could literally run a SpacetimeDB cluster with 400 Raspberry Pis, and then that's 400 times 2,000 people. And what you would do is you'd have each region of the world, and there's a lot of details with this because you have to do all the inter-module communication. There's a lot of networking involved, but each region of the world handled 2,000 people. Now all of a sudden you've got a cluster that costs you $50, sort of. Not really. It's like a couple $1,000s, and you're running with hundreds of thousands of CPU. That's something that MMO companies cannot even dream of right now. That's not even close.
What do you think, Tyler?
The sky is the limit. Let's hit them with more bots, shall we?
Yeah. How many bots would you like to add?
Double it. What's the that's getting a little bold, but what's the CPU usage?
What is the CPU usage? Let's take a look. Okay, we're sitting at it's jumping around a little bit. It's getting more variable, I would say. So we are kind of in like the low 30s or mid 30s, sometimes hitting in the very low 40s. around there. So yeah, I would say mid 30s is where we're at right now.
We could double it. I think so. What you're seeing, because we're slamming on all cores, is that it's starting to be that the subscription evaluation, which can be improved in terms of performance very significantly. Like we're not bottlenecked on single-threaded workload right here. This is all multi-threaded, so I think we can goose that up more and be good. But Kochu fan notes: AMD EPYC 9754 is only 2.25 gigahertz and does have 256 threads though, and so what you need is software that can take advantage of those threads. And the best multi-threaded software these days is databases. So if you want to have as many people on one machine, as many players playing in the same server, you need a database. That's basically what. So how are we doing with number of bots?
So we currently have 128. We can go ahead and bump it up. So I'll go ahead and stop the ones that we have. What do you want to bump it up to? What would you like the number to be?
We can try to double it. I think that's going to be around our breaking point.
Okay. So what would you like to do?
Let's try it. Let's double it. Let's go.
Double it. Okay.
I mean, what do you think?
I think that's fine. I think I like the pattern. So we'll go ahead and spin up 128 replicas on these two machines.
And I will watch in my game to see how slow it gets.
So there is a... Oh, sorry.
It's struggling a little bit, I think.
Oh, is it? Yeah. There is going to be a performance hiccup at the start with all of the bots connecting, because the thing that it has to do is all the bots have to download the entire, all their world state, which is a little bit more CPU intensive. So I would expect for there to be a little hiccup here at the start, but we'll see if we can handle it here. We'll see. So this is 256 bots.
Right. And you can see we still have performance to be gained in two ways. One is we're not maximizing every CPU at all times. And the other is we're probably doing a whole bunch of nonsense that we don't need to be doing. So if we fix those two things, you can do even more.
So obviously 256 may be reaching the point here where this is too many bots. Clearly the bots are still moving though. There is some lag. It seems like the Raspberry Pi is maybe not able to catch up now after, having all the bots connected and everything. So it seems like we're probably at the limit here. I think we could probably squeeze a little bit more performance out of this if we were on the 8 GB variants. There's probably a small amount of swapping going on here. And the SD card is particularly slow. I'm not running this off of an NVMe or anything. It's literally running off of a micro SD card, and actually that's why it was so slow to get Bitcraft loaded, is because it's literally Bitcraft was saved to an SD card. So essentially that's why it took a couple minutes for Bitcraft to actually get loaded into memory and up and running.
Can we get the H-top?
Yeah. So yeah, we're sitting high 50s, maybe around the 60s,
right.
Low 60s.
Which tells us only one thing: there's more performance on this Raspberry Pi to be gained. We can run it more, and we can do less work. And this is a $60 computer. We're running a game server with 256 users. Now, granted, the lag is pretty high at this point, but somewhere between 128 and 256, that's a huge amount of players for any game, right? So this is why performance is critical, and there's still more. There's ever more to be gained.
Yeah, I almost wish we would have done this exact same thing a year ago, although we probably wouldn't have done it live on stream because it wouldn't have been super impressive. But it'll be crazy. We should do this a year from now, is what we should do. We should do it a year from now, and I bet you're right. Is your prediction that we'll hit 1,000? Is that your prediction, Tyler?
Yeah, that's my prediction. I think we could maybe even do that, let's say, before a year. It depends on what our priorities are.
Right.
But yeah, I think that's totally achievable.
Cool.
Cool.
So I do have a meeting I have to run to in 15 minutes. I'd like maybe just a small amount of time to eat. Thank you for the follow, Logan M. Butler. Very much appreciated. Hope you're doing well. So yeah, I think this was pretty much the demonstration I wanted to do. I'm trying to think if there was anything I wanted to do at the end to wrap it up. Maybe I'll just, do you care if I just shut the machine down just to show that we are actually running on this Raspberry Pi? Should I unplug it? I guess one thing that would be is, should we unplug it and start it back up?
Sure.
Okay, we're gonna have a server outage maybe.
But yes, but I want to show that the changes you've made to the world, like just now, like basically chop a tree down.
Okay.
And then unplug it, and then show that the tree has been chopped down. I think that's cool.
Sure. Let's go to something quick. Hopefully the lag is somewhat reasonable here. Let me stop some of the bots here. Down, Docker down. Yep. Okay, so I've just destroyed that bush. I'm going to destroy this bush. I literally am going to unplug the Raspberry Pi. I'm going to simulate hardware failure is what I'm going to do here. What do you think about that?
Sounds good.
Okay, let's do it. Actually, what I want to do is I want to like do it mid chopping something. So here's this bush here as well. Okay. All right. Maybe we're failing over to our backup environment or something now. Okay, obviously this is no longer. Gonna go ahead and wait for this to start up. Okay. See? Backup environment. Yes, we do have a backup environment for Bitcraft. In case this were to happen, we can fail over to a backup environment.
Eventually, post 1.0, SpacetimeDB will automatically fail over. So if you are running a server and it goes down, it will automatically fail over to another one, and your users should not know. It might have a latency hiccup.
Okay, so we've got this machine is loading Bitcraft from the SD card here. It's reloading the database here, and we'll just see. We'll go ahead and see all of our RAM go bye-bye. But this only has it only has 4 gigabytes of RAM, so this is really not a lot of RAM, especially considering that, as Tyler said, this is literally an entire backend to an MMO running in 4 gigabytes, which I think is even more impressive, honestly. You should be able to reconnect now to the Raspberry Pi. So essentially what we did is we pulled the power on the Raspberry Pi while it was just in the middle of doing stuff. And we plugged it back in, we reloaded the database, and let's see. Okay, so those 2 bushes might have actually just resource regened. Let's see if this one's partially damaged, and it is. Okay, so that only had 8 out of 10 health remaining on this bush. These other 2 bushes are back, but I think that's just because of resource regeneration. The bush that I just cut down just now was partially damaged. So essentially, it saved the state up to where I had damaged it up to 8 damage. So actually, was it? Maybe these 2? No, I think I did cut down these 2, but I think they might have just resource regened. I think the bushes regenerate pretty quickly. Cool, so it works. Awesome. I hope that everybody had fun watching this video. We had a lot of fun making it. We had a lot of fun playing around with the Raspberry Pi 5. And actually, we want to do more Raspberry Pi 5 content in the future if people are interested in it. Like maybe potentially doing like GPIO pin stuff, or potentially even running a SpacetimeDB cluster on the Raspberry Pi 5. So if you guys are interested in seeing that sort of video, definitely leave a comment down in the description. It's a video that I really want to make. And we'll make it if people are interested in it. So again, thank you for watching. We really appreciate it, and we'll see you next time.